Welcome to the lesson on current. In this lesson, we will explore the concept of electric current, ampere, as a unit of measurement, and its importance in the battery electric vehicle systems. Let us look at our lesson objectives. By the end of this lesson, you will be able to define electric current and explain its role in battery electric vehicle operation. Next, you will be able to explain the concept of ampere as the unit for measuring current. Finally, you will be able to describe the relationship between current, voltage, and resistance in battery electric vehicle circuits using Ohm's law. Battery electric vehicles rely heavily on electrical systems. Current is essential for a battery electric vehicle as it powers the flow of electric charge from the battery to the motor, enabling the vehicle to move. Understanding the fundamentals of electricity is crucial for diagnosing, repairing, and maintaining these vehicles safely and effectively. This lesson will introduce you to the concept of electric current, its measurement unit known as the ampere, and its importance in the battery electric vehicle system. In this lesson, we will focus on the concept of electric current, its measurement unit in amperes, and its importance in battery electric vehicle systems. Current is the rate of the flow of charge. The current in a conductor is measured by the amount of charge, number of electrons, that flows past a certain point in a unit of time. Imagine a river. The water flowing through the river represents an electric current. Just like the river has a flow rate, electric current measures the rate at which electric charges, primarily electrons, move through a conductor, like a wire in a battery electric vehicle. The more electrons are flowing per unit of time, the higher the current. You can also imagine a busy highway with cars passing you. The cars represent electrons, and the highway symbolizes the electrical circuit. Just like how we measure the rate of traffic flow in terms of the number of cars passing a specific point on the highway in a given time, current measures the rate of electron flow in a circuit. The more cars that pass a point on the highway in 1 minute, the higher the traffic flow. Similarly, the more electrons that pass a point in the circuit per second, the higher the current. Current represents how quickly electricity flows and powers devices. Ampere is named after French mathematician and physicist André-Marie Ampere, 1775 to 1836. He is considered the father of electromagnetism along with Danish physicist Hans Christian Ørsted. The Ampere image is a demonstration model of a moving iron amperemeter. As the current through the coil increases, the plunger is drawn further into the coil, and the pointer deflects to the right. An ampere, or amp, is the unit for current. This is symbolized by the letter I. Similar to how we measure water flow in gallons per minute, amps tell us how much electrical charge passes a specific point in a circuit every second. Think of current, amps, as the amount of water flowing, voltage, volts, V, as the pressure pushing the water, and resistance, ohms, omega, as the obstacles in the riverbed. A higher voltage creates a stronger push, potentially leading to a higher current. If resistance is low, resistance acts like a dam, restricting the flow of current. This relationship is described by Ohm's law. Ohm's law describes the relationship between three key electrical quantities: current, voltage, and resistance. In this relationship, I, current in amps, equal V, voltage in volts, divided by R, resistance in ohms. This equation allows you to calculate any one of these values if you know the other two. For example, if you know the voltage of a battery electric vehicle battery, example 400 volts, and the resistance of a wire, example 0.1 ohms, you can use Ohm's law to determine the expected current flowing through that wire. I equal 400 volts divided by 0.1 ohm equal 4000 amps. Understanding this relationship between current, voltage, and resistance is crucial to ensure proper current flow to avoid problems like overloaded circuits, as excessive current, due to low resistance or high voltage, can cause overheating and damage to wires and components in a battery electric vehicle. Let us now recap what we have covered in this lesson on current. The flow of electric charge, electrons, through a conductor is measured in amperes, amps. A higher amp reading signifies a larger flow of charge per second. An ampere is the unit used to measure electric current. It represents the rate of charge flow, similar to how we measure water flow. Current, amps, voltage, volts, V, and resistance, ohms, omega, are interrelated by Ohm's law, I equal V divided by R. Voltage acts like the pressure pushing the current, while resistance restricts the flow. Understanding current flow is crucial for battery electric vehicle technicians to diagnose issues like overloaded circuits due to excessive current or power loss from insufficient current. Thank you.